Okay, we are in chapter 10, sequences and series. So in mathematics, a sequence is an ordered list of numbers called terms. And the terms are often arranged in a pattern. So here we go, 0, 3, 6, 12, ... The 3 dots are called an ellipsis. And it indicates that the sequence is an infinite sequence, like it's continuing, it's going on forever. It continues to that end. A finite has a last term, would be the opposite of infinite, okay? So it's like when you were young and you have to complete the pattern. If you were good at completing the patterns, usually you went to a higher math course, okay? So it says find the next two terms of the sequence. The sequence here goes 2, 4, 6, 8, 10, and naturally, instinctually, you'd say 12 and 14. This was a common difference of 2, okay? Here, 4, 8, 16, 32. We see we're doubling every time, so the next two terms would be 64 and 128. This would have a common ratio of 2. And once again, I want you to try these two and then check. So try 3 and try 4. And we see here there's a common difference and a common ratio. A lot of times in sequences, there's also other patterns where you're multiplying and adding or you're squaring something. But in these specific ones, and they're the ones that we're focusing on, there are arithmetic. Some people say arithmetic, that's fine. Arithmetic, which it means just adding a common difference every time. And there's geometric, where you're multiplying by a common ratio every time. Okay, so arithmetic sequences. Look at the following sequences. What are the patterns? Here you're going up by 4, so the common difference of 4. And here there's a common ratio of 2. It says example 1 is different from example 2. It differs by exactly the same number, and this is called an arithmetic sequence. So it's a sequence whose successive terms differ by the same number D, called the common difference. You can pause to copy. So an arithmetic sequence is a sequence whose successive terms differ by the same number D, called the common difference. So we'd say here we have a common difference of 4. Are the following sequences arithmetic? Yes. The common difference is 3. No, there's no common difference. Is it possible? It is possible to write a formula for the sequence. Okay, so if I asked you to write a formula for that, could you? Yeah, you could. You'd say, okay, well, I'm adding 3 every time. Plus 3, plus 3, plus 3 to what? X. Then how do you know what X is? Okay, so it's called a recursive formula. With this, one or more previous terms are used to generate the next term. So for this sequence, 1, -1, -2, -5, and -7, we see that we have a common difference of -2. So we're subtracting 2 every single time. So I start with my first term, and I subtract 2 every time. So what it's saying is you have to tell the reader what the first term is, because what you're doing is recursive. It's like reoccurring. It's using the previous term. So you need a term to work with. You start on the second term, and you subtract 2 every time. So if I want to find the third term, 3 is my n. 3 minus 1 would mean that's the second term. And what you're doing every time is subtracting 2. Okay, so my third term is my second term minus 2. Second term minus 2. Yeah, that's my third term. So this is term 1, this is term 2, this is term 3, this is term 4, this is term 5. Okay, we have to start at 2. So for instance, if I want to find the second term, it has to be the first term minus the second term. So if I start here, it's -1. Well, I want to find -1, so I take my first term and subtract 2. You can't start with your first term because you don't know t sub 0 or the one previous, because there is nothing previous. So you have to start with the second term, give the reader the first term, and then that's your formula. So let's go back to example 3 and write a recursive formula. Here, we're adding 3 every time. So whatever term I'm trying to find, I have to take the one before it and add 3. The one before it is -1. You have to tell your reader what the first term is, so they have something to work with. And you say, hey, reader, you have to start with the second term or greater. We've covered our bases. Okay. It says, now find the first 6 terms of a sequence given with a formula. So now we have a formula, and we need to find 6 terms. So it says the first term is 4. The second term is the first term plus 3. First term plus 3. 7. The third term is the second term plus 3. 10. The fourth term is the third term plus 3. The fifth term is the fourth term plus 3. The sixth term is the fifth term plus 3. So did I go by 3s every time? 4, 7, 10, 13, 16, 19? Yes. Okay, so that's recursive formula, reoccurring. All right. Now let's talk about geometric. It's the same thing. We said that there's actually multiplication this time. A geometric sequence is a sequence in which the ratio of successive terms is the same number r, called the common ratio. Are the following sequences geometric? Yes. I'm multiplying by 2 every time. Here, I'm multiplying by, oh, looks like I'm dividing. When you're dividing, you are still multiplying. You're dividing by 3, you're dividing by 3, you're dividing by 3, so you're multiplying by a third. Okay? Or what you could do is say, all right, what's 6 divided by 3? 2. What's 9 divided by 27? 1/3. So a recursive formula for a geometric sequence is the same thing. It's your first term, whatever term you're trying to find, you take the term before it and multiply it by r. Same thing. Okay? So if I wanted to find the formula for the first one, you'd say it's whatever term you're finding, it's the one before it times 3. Same thing here. Whatever term you're finding, it's the one before it times a third. Okay? Or you could rewrite it this way. 3 times the previous term. 1/3 times the previous term. But you have to say, hey, reader, you want to start out with the second term because you can't start out with the first term because there's nothing before it. But you also need to give the reader something to work with. That first term is 3. That first term is 27. And I mean, I'm not really particular on the order on how you put those. It says, let's review. Okay, so I want you to pause the video and I want you to try these on your own. And I want you to come back and check. Are they arithmetic, geometric, or neither? Here, you're adding not the same thing every time or multiplying. 12 divided by 8, 20 divided by 12, it's not the same thing, so it's neither. And that's fine. It can still be a sequence. Here, we are subtracting 4 every time. It says, if it's arithmetic, state a recursive formula. Well, my first term is 2. I'm going to start using my second term. Whatever term I'm trying to find, it's my previous term minus 4. So that's pretty much what we just did. It says, write the first 4 terms of the sequence. Here is the only one that's a recursive formula that we've done. So if I'm trying to find the first term, okay, I'm going to put a 1 in. Are any of these? No, none of these are recursive, but that's fine. So let's put a 1 in for all of them. I put a 1 in. I get 19. I put a 1 in here. I get 0. So I get 2. I put a 1 in here, I get 4. Try the rest on your own. What's happening every time? We jumped up 3, we jumped up 3, we jumped up 3. So it's arithmetic. Even though that's not the kind of formula we use, that's fine. Here, keep putting numbers in. Oops. Yeah, we're multiplying back and forth by a -3. So this is geometric. And lastly, you're not adding the same thing every time, and you're not multiplying the same thing every time, so it's neither. Well, it's obvious. It's a quadratic. Okay? All right. Last part means the terms between any two non-consecutive terms of a sequence. So if there's 4 numbers that are not directly after, it's 24 and 39, okay, these are the means. There's 4 numbers in between here, but we know it's arithmetic, so we know there's a common difference every time. So I want you to pause, and I want you to try to see if you can figure out what those numbers are. If you can't, well, let's think about this. We know that we're going to add a common difference every time. So we have how many common differences if we have 4 spaces? We have 5. So I'm going to add 5 common differences to 39. So if I were to solve for that, I get a common difference of 3. So the numbers would be 27, 30, 33, 36. Try the next one on your own. Pause the video. So we have 6 common differences if I have 5 numbers. That means your common difference ends up being a -2. Therefore, your numbers are 4, 2, 0, -2, -4. And make sure that jump is still a -2. You don't just put some number and it doesn't work out. All right, here now we're saying geometric. So I'm going to multiply. Okay. Well, I have 1, 2, 3, 4, 5. Okay, 5 jumps. I'm multiplying 5 R's. So it's 4 times R times R times R times R times R equals 972. So it's 4R to the 5th equals 972. If I divide both sides by 4, and in my calculator type 5 math button asterisk 243, I will get R is 3. That means if I multiply this by 3, it'll be 12, and then 36, and then 108, and then 324. And does 324 times 3 give me 972? It does. Okay, I want you to try the last one on your own. Okay. I want you to do this one. I want you this to hit home and make it so important to you that I want you to do this one on your own. And if you get it completely correct, you'll get a free homework quiz. Or you have to hand in the homework assignment because it's one of the most important pieces.